So, you open up the AWS console to launch a new server, you look at that long list of EC2 instance types, and your eyes just glaze over. If that sounds familiar, trust me, you are not alone. It's a super common hurdle, but today, we're going to make sense of it all. Right? It's just this endless menu of kind of cryptic letters and numbers. But what if I told you there's a simple logic behind it all? A way to quickly slice through those hundreds of options and find the perfect one for whatever you're building. Well, by the end of this, you'll have the map to do just that. Okay, so before we can pick one, let's just quickly nail down what an EC2 instance is. At its heart, the instance type you choose is really just the virtual hardware your application is going to run on. It's the decision about how much processing power, how much memory, and what kind of storage your cloud computer is going to have. To make this all really easy, we're going to use a simple analogy. Think of choosing an EC2 instance like picking the right vehicle for a specific trip. You wouldn't take a Formula One car on a camping trip, right? And you're not going to use a giant moving truck to try and win a drag race. It's all about matching the tool to the task. First up, we've got the general purpose instances. These are the family sedans of the cloud. They're reliable, they're versatile, and they give you this fantastic balance of compute, memory, and networking. They might not be the absolute fastest or the biggest, but they are the perfect, well-rounded choice for a huge variety of jobs. And this is exactly why they're the sedans of the cloud. They have plenty of power for your everyday web servers and microservices, but they're also efficient enough for things like code repositories or your dev and test environments. They're the real jack of all trades, which makes these M, T, and Mac instances the default starting point for most applications out there. Okay, so we have our reliable sedan, but what if you need pure, raw speed? Well, meet the compute-optimized instances. If general purpose is the sedan, this is the stripped-down, high-performance race car. It is all about one thing and one thing only: raw processing power. Everything is optimized for the CPU, the engine. So what kind of job demands a race car? Well, pretty much anything where the CPU is the bottleneck. Think about media transcoding, where every single second you shave off processing a video saves you money. Or maybe dedicated gaming servers that need to react instantly. If your task is CPU-bound, this is your ride. But what if you don't need top speed? You just need to carry an enormous amount of stuff. That's where memory-optimized instances come in. These are the cargo vans of the cloud. Their biggest feature isn't the engine size, but the huge amount of space they have inside to hold things. In this case, data in RAM. And, AWS themselves really put it best here. The key phrase is in memory. Whenever your entire dataset needs to fit into RAM for instant access, like with big in-memory databases or real-time analytics, that is when you load up this cargo van. But what if your data is so massive it won't even fit in the cargo van's RAM? Well, then you gotta call in the heavy-duty truck. Storage-optimized instances are built for workloads that need incredibly high, fast, sequential access to huge datasets that live on local storage. We're talking about reading and writing massive files from a disk at lightning speed. And the spec that really proves it is IOPS. That's input-output operations per second. You can think of it as how many tasks the disk can juggle at once. These instances are built to handle tens of thousands of those requests every single second, which is exactly what you need for things like data warehousing, search engines, or massive scale analytics. And finally, we get to the most exotic category: accelerated computing. Now, this isn't just a race car. This is a highly specialized vehicle, kind of like a Mars rover or a jet fighter. It's equipped with extra hardware. We're talking coprocessors like GPUs that are designed to do very specific, very intense jobs way more efficiently than a standard CPU ever could. So what are these coprocessors built for?
Basically, everything a normal CPU struggles with. We're talking the heavy-duty math for scientific modeling, the parallel processing needed for graphics, and, of course, the technology that is defining our era: machine learning. If you're working with AI, these aren't just an option, they're pretty much essential.
So now we know the vehicle categories: sedan, race car, cargo van, truck, and specialized supercar. But when you look at the list, you see names like M7G.large. So how do you read the model number? Well, it is time to decode the secret language. This is where it all clicks. Let's break down M7G.large. The first letter, M, that's the instance family, our general purpose sedan. The 7 is the generation. Think of it like the model year. Higher is always newer and usually better. The G tells you about a special feature, in this case that it uses AWS's own Graviton processor. And finally, .large is just the size, or the trim level. It's a simple pattern: family, generation, features, and size. All right, so we can pick our vehicle and we can read the model number. Now let's pop the hood and take a look at the engine, the different performance options that you have. You've basically got two choices. Fixed performance instances are like a powerful V8 engine that's always on, ready to deliver 100% of its power at any moment. Then you have burstable performance instances, which are usually the T family. Think of these like an efficient hybrid engine. They give you a baseline level of CPU for normal traffic, but can burst to full power for short periods when you need it, which makes them incredibly cost-effective for workloads that are mostly idle but have occasional spikes. And underneath almost all modern instances is something called the AWS Nitro system. Just think of this as the advanced chassis for our vehicle. It's a system of dedicated hardware and a special hypervisor that offloads a bunch of the networking and storage tasks. This frees up way more power for your application, which gives you better performance and security. Okay, we now have all the core concepts, the categories, the naming convention, and the performance models. So let's put it all together and see how you can navigate this landscape and scale your resources. This is where the system's logic is just beautiful. Look at how scaling works within the M7i family. Say you outgrow your .large instance. Well, you just change the size to .xlarge. And notice the super predictable pattern? Your vCPUs and your memory just double with each step up. You're simply getting a bigger, more powerful version of the same reliable sedan. And here it is. Probably the single most important piece of advice, straight from the AWS documentation. When you're launching new instances, always try to use the latest generation available. An M7G is going to give you way better performance for your money than an older M6G or M5G. It's like buying the latest model year of a car. You get all the new efficiencies and features, often for the same price or sometimes even less. So, that intimidating list of options? Yeah, it's not so scary anymore. You now have the map. You know the right vehicle for the job. You can read the model number, and you can choose the right engine. The only question left is, what are you going to build?